All right, let's take care of part D. We're given two polar curves. One is R1 equals A times 1 plus cosine theta, and R2 equals A sine theta. Here, A is just a positive number, and to be able to plot this, you should probably assign a number for A. And I did that just for A equals 1, just to get the visual, because when you increase A, you're going to expand the graph. So nothing's going to change except the graph is going to enlarge all the way. All right. So please have your TI-84 and take A to be 1 and also plot both of these functions in the same graph. And please choose your theta min to be 0, theta max to be 2 pi, so that you can actually see the full picture of these two curves. And you should be able to see this type of visual. Okay, so R1 is the blue graph. Let me just write here R1, and R2 is the circle. Okay, and I can see that these two curves, first of all, intersect at two different instances. One is this, and the other one is this. Okay, and the common interior that's mentioned in the problem statement is this yellow region here. Okay, and I don't think that we're going to be able to find the area of this region in one shot or in one integral. We're going to try to find it like in two different integrals, but I'll come back to that. So right now I want to consider this table here. Please have this table in the meantime so you can actually see where the intersection happen and which direction those curves go. Like for example at 0, at theta equals 0, R1 is 2 and R2 is 0. So the first graph is going to, the blue graph is going to start from this point, and R2, which is the circle is going to start right at the origin. Okay, so let's see how what the direction looks like as we increase theta. So let's look at pi over 6. At pi over 6, R1, the blue one, takes the value of 1 plus radical 3 over 2, and the other one is just 1/2. So here we go. So this guy moves like this, and then this guy moves like this. Okay, so that's good. And they move all the way till they hit theta equals pi over 2 ray, and these two curves intersect. Okay, so the first intersection happened at theta equals pi over 2, and different from what you see or different from what you expect from the graph, the first intersection do not happen at theta equals 0. Okay, because at theta equals 0, these two guys have different theta values. Okay, and at pi over 2, where the intersection happens, both take the value of 1. And I want you to stare at theta equals pi. Both take the value of 0, and that's where the intersection happens. Okay, so this is theta equals pi, and on that ray, these two guys intersect. Okay, so I want to sort of like I want to sort of like obtain this analytically. Okay, so let's set the equations equal. And at this moment, it doesn't matter what a is because you can divide both sides by a, even though I had to take it like 1 to get a visual, but now I cancel them out, and they don't, I mean, a doesn't have any contribution towards solving this equation, okay? So, and this is 1 plus cosine theta equals sine theta, all right? And you may start thinking about how you can attack solving this problem. And visual is really helping us because we just said that the first intersection happens at pi over 2, and there's no like simple way to solve this equation in one shot by using the unit circle, but I can go ahead and plug in pi over 2 here and see if the equation is satisfied. Cosine pi over 2 is 0, and sine pi over 2 is 1, and 1 plus 0 is equal to 1. So I put a check mark here, so that means theta equals pi over 2 is one of the solutions. And I can do the same thing for theta equals pi. Okay, so pi and pi here. Well, cosine pi is -1, so 1 plus -1 is in fact equal to sine pi, which is 0. So I can also visually, like in this regard, the visual helped us to solve this tricky equation because it's not easy to see that the solutions here are pi over 2 and pi. Okay, it's not easy to see that because we don't have any like sine theta equals a number or cosine theta equals a number, so that we can use arc sine or arc cosine of that. But the easy detour in this regard is just to get the help from the visual. Okay. All right. Once we have the intersection, so we may start thinking about how we can find the area of the common interior. But one observation here is that the common interior is split into two parts. Okay. One part is this part here, half of this circle. Okay, I'm going to call this 1. Let me just circle that. And the second part is this part. And I'm going to call that region to be 2. Okay. The region 1 is an easy shot because it's even like half of the circle, and we know how to find the area of the circle. And you can just like find that area for the diameter to be exactly equal to 1. So the radius is 1/2. So you know how to find the area of a circle with radius 1/2, right? So pi r squared is the formula. I can right away tell you that 1 has the area of 1 is 1/2 of the area of the circle. So it's 1/2. Let's see, pi r squared, right? Pi r squared, which is pi times 1/2 squared. I don't even need to go through this integration business to find this area. It's pi squared over 8, in fact. Okay. Once I take care of that, I can consider finding the area of the red part, right? So we intersect here. We can use the blue curve starting from here all the way to theta equals pi. So in other words, when I change theta equals pi over 2 and sweep all the way through theta equals pi over 2, I am going to, let me just clean this up to rewrite something on that. So I'm going to get this area all the way swept. Okay, and I'm using only R1 for that, the blue curve for it. Okay. So why don't we go ahead and write down. So area of 2, let me just use this color here, is 1/2 integral from pi over 2 to pi, and I'm going to use R1 as I said. R1 equals 1 plus cosine theta. But we also, well, we took A to be equal to 1 to start with, so I should go with the original R1 involving A, okay? And same for, by the way, for the area of the circle, okay? So I'll come back to that again. Even though I calculated that here, the radius is not 1, but A over 2. Okay, let me just correct that here real quick. Okay, so here, this is A over 2, so you should have A squared coming along with that. So pi squared A squared over 8 is in fact the area of the circle when you do not take A to be 1, okay? So go back here, and we have A times 1 plus cosine theta squared. There we go. Okay. And that has A squared, and we can pull it out. So A squared over 2, pi over 2 pi, 1 plus 2 cosine theta plus cosine squared theta. And I'm going to use the power reducing formula that we have been using that for a long time for cosine. So cosine 2 theta plus 1 over 2 d theta. Okay, we're using power reducing formula to replace cosine squared by cosine 2 theta plus 1. Let's just do this in one shot. Let's just find the antiderivative. All right, a squared over 2 theta plus 2 sine theta plus 1/2 sine 2 theta plus theta. And here the limits are pi over 2 and pi. Okay. right. All right, so let's plug in the upper limit. A squared over 2 pi, 2 sine pi, 1/4 sine 2 pi, and pi over 2. Minus a squared over 2, let's plug in pi over 2 this time. 2 pi over 2 plus 2 sine pi over 2 plus 1/4 sine pi plus pi over 4. All right. Well, sine pi is 0, so is sine 2 pi. So these terms are gone. And sine pi over 2 is only equal to 1. Okay. All right, let me just clean this part up, and I'll come back in a second. All right, after we simplify everything, I cleaned up everything so that you have a fresh start here. So we got exactly this. So this is a squared over 2, 3 pi over 4 minus a squared. Okay. So let's find out what the area of 1 is. But be careful because we are given in the original statement of the question, we're given a here, right? A here. So let me write down the area of the half the circle is pi squared over 8. That's not true because the radius is not 1 over 2 because we have a as a parameter over there. So a is this. A is the length of this whole thing. Okay, so let me just clean this. So a is right here. Okay, so and the radius of that is not going to be 1/2, but a over 2. So let's correct that right here. So this is a over 2, and then I should have a squared coming along with. Well, there's no pi squared, by the way. There's a typo, so that should be pi a squared over 8. Okay, so. Okay, so pi a squared over 8. So go back here and write down pi a squared over 8 for the area of 1. So the total area is the sum of these two numbers, okay, this and that, okay. So a squared over 2, 3 pi over 4, minus a squared plus pi a squared over 8. Okay. So you can simplify this further if you want to. But I'm going to leave it right here because this video is already a long video, and as I see that our strategy was to split the interior into 2 parts, okay? And one part is this, and the other part is this, and we took care of each area separately. And we used something from geometry, so the area of the circle. In fact, we needed the half of the area of the circle. We had the formula for that. Once you know the radius, you can find that region here, number 1. In fact, right, number 1 we called it. Okay, and for number 2, we had to use the integration. Could we use the integration for number 1? Yes, we could. In fact, at that time, we would be working with R2 and the integration, and we would be integrating from 0 to pi over 2 of 1/2 sine squared theta. Okay. All right. So this is the end of the video, and thanks for watching. And if you have any questions or comments or suggestions about the format of the videos in general or some other stuff or the content of the videos, please send those to my way. I'll try to address them. And thanks for watching. I'll see you in another video. Bye.